So following on from our calculus in physics video, what we found was that when you integrate certain quantities, for example, integrating an equation for velocity, you can get displacement, but you also get a constant. What we want to do is look at different ways of figuring out what that constant means. So I'm just going to carry on with the example that we got to, which was integrating an equation for velocity. So on the left-hand side, over here, we've integrated the general equation for velocity, and we've got v naught t plus a half at squared, which is familiar, but we've also got this plus c term. If we concentrate on the right-hand side and look at what we've got when we put some numbers in. So here we started with an equation of the initial velocity being 10, and an acceleration of 1.2 multiplied by t gives us the velocity. So we integrated that to give an equation for displacement, which is what we've got down here. But we got also, from the integral, a constant. So there's multiple ways of looking at this, but one of them is just to see what happens when you put extreme values of your variable in. So for example, a place to look at this would be what happens if we put t naught in. So if t equals 0, then as you can quite clearly see, those two terms would become nothing, plus c. So quite clearly, when t equals 0, s equals c. Now, you've got to keep track of what all this means. If you're just working mathematically, this doesn't help. But we know that the time, of course, is t, and that s is the displacement. So what we're really saying is that the displacement at time 0 is c. In other words, c is the initial displacement s naught. So in our general equation, if we come back over to the left-hand side, we can have s equals v naught t plus at squared over 2, or half at squared if you prefer, plus s naught. Now, in actual fact, when you get onto undergrad physics, this will be written exactly like that, but probably in terms of x. And that's where that comes from. In a lot of examples, when you're just measuring how far something's travelled, you'll tend to measure it from its starting point at time 0. So quite often x naught is 0. But this is useful, for instance, if something starts a distance of 10 metres away and then starts to accelerate from there, and you want to know how far it ends up after a certain distance, this extra term actually is very useful.